All right, Explorer, it's that part of the week when we get incredibly bored of life down here on planet Earth, so let's see what the other planets are up to. It's a brand new Fun Kids Science Weekly. My name is Dan. This is the show where we explore all that strange science lurking through the universe. This week, we've got a brilliant question to answer, which I can't believe I've never thought of before. We'll find out if fish actually drink water.
It's a really interesting question. But if you're a fish, you've got a couple of different problems. And it depends whether you live in salty water or whether you live in fresh water, like the sort of water that we would drink from the sink. If you live in salty water, it can actually be quite a big problem.
Also, our quest to find the greatest science in the universe has us looking at your brain and the decisions that you make.
We have to prioritise ourselves at some level, but because we're social creatures, we have to make collaborative decisions, right? And that's actually one of the hardest things to study, which is how we work with others to make group decisions.
And our Dangerous Dan is all about a tree with many, many ways to hurt you. It's a terrifying tree. So let's get to a brand new Fun Kids Science Weekly. We'll start with your science in the news. This is strange. Someone has moved the UK's oldest satellite, and there appears to be no record of exactly who, when, or why they've done it. Skynet 1A was launched in 1969, just a few months after humans first set foot on the moon. It was put high above Africa's east coast to help out the British forces at the time. But today, Skynet 1A is the other side of the world. It's in a position over 22,000 miles above the American continent. And experts say it's quite unlikely that this half-ton military spacecraft simply drifted above the Americas. They think it was commanded to fire its thrusters and move there about 50 years ago. But no one really knows who told it to do that, or even why. How strange. There's something so important. I mean, it's floating above our planet. We've put it into space. Yet we've completely lost track of what's going on with it. How bizarre. Also, this is some bad news. It's now virtually certain that 2024, this year, which has had intense heat waves and deadly storms, it will be the world's warmest year on record, according to projections by the European Climate Service. These high temperatures are mainly down to human-caused climate change, with smaller contributions from natural factors like the El Niño weather pattern. And scientists say that this should act as an alarm call, and it reminds us that we need to do better to help the world. And our final story this week, an incredibly rare female baby hippopotamus has been born at Edinburgh Zoo. The tiny endangered pygmy hippo calf named Haggis arrived on the 30th of October. Zookeepers have said her personality is beginning to shine already. Let's find out more with Jonny Appleyard from Edinburgh Zoo. Jonny, thank you for joining us. How is Haggis?
Yeah, she's doing really well. She's put on about 5 kilos in a week, so she's growing.
Well, so she was born on the 30th of October. How long has this been planned to bring one of these incredibly rare species to Scotland?
Yeah, quite a while. We've had the male and the female for quite a while now. They have bred with us before, so we've had one before, and she's currently in residence at London Zoo, which was the first daughter from Gloria and Otto. This is their second daughter. So this is the first one we've had in a few years, so it's quite exciting.
It's amazing you say that Haggis's sister is in London Zoo. And so zoos all work together to boost numbers of the species. How does that work? How are you talking to one zoo here, maybe another zoo in Australia to figure out all this?
Yeah, so basically what it is, it's basically a big network. So if you imagine like Facebook, but it's a bit bigger, and every zoo's got contacts at every other zoo. And what we do is we work together as a big global network or European network, more like it. And what we do is we none of us really own the animals, if you see what I mean. Like we do our best to look after them. So what we do is when they get to a certain age, when the baby's born, obviously you only have a certain amount of space within the zoo, so you can't keep them forever. So what we do is then we move them on and we work we've got what we call a stud book, and what that is, it's a list of all the animals in the population, and what they do is they find the best genetic match, so the best individuals that are most likely to mate to be able to produce offspring. and then what we do is we try and pair them off. So once they get to a certain age in the wild where they would leave their mother, that's at the time we would then move them on to another collection. Sometimes they'll join zoos and they'll be with other individuals of the same sex, like with giraffes or rhinos, where they get to an age where they're not quite at the age where they'd want to be meeting with females. In the wild, they'd go off and they'd kind of have an age of development and play. So we try to mimic that as much as we can. But with hippos, they get to a certain age and then they're solitary after that. So what we do is we move them off to a zoo that's looking for a female or a male, and they'll most likely join the opposite sex.
Haggis has been called incredibly rare. This is a pygmy hippo calf. How seriously are they endangered?
Yeah, in the wild, there's only about 2,000 left, so there's not a lot of them around, and they do often get overshadowed by the bigger cousin, obviously. Most people, when they think of hippos, they think of the common hippo, and the pygmy hippo is obviously the size of a really, really, really fat Labrador, essentially. They're not massive, so people sometimes forget about them. They're only really found in West Africa, so they're only in one area of the world, so people actually forget about them a lot, and obviously with the big cousins always on the welfare shows and all that lot, they're not often found. They're a lot more exclusive than the big hippos. Obviously, they're a lot more common to see in the rivers and stuff, whereas these guys tend to spend more time on land, in the shrubs and stuff, and only really come out at dusk and dawn.
Well, because of that, because haggis and pygmy hippos are endangered and perhaps more unique than their common cousins, what preparation does Edinburgh Zoo need to do, and has it done, to take care of something that's so unique like this, a baby pygmy hippo calf?
Yeah, I mean, surprisingly, most animals adapt to the climate they're in. Obviously, Scotland is a lot colder than it is in Africa. But obviously, when they're born in this area, they kind of build up a tolerance. Obviously, that being said, they're biologically built in a way that means that we have to make some precautions. For example, that their skin, they've got a lubricant in their skin that they secrete to stop themselves getting sunburned. So that's good during the summer, but it's not necessarily good in the cold climates of Scotland in the middle of winter. So at the time of year when she's born now, she's probably not really going to realistically be outside for at least 3 or 4 months now, because it'll be too cold, and they're very susceptible to pneumonia. And the reason that is because they've got a really thin layer of skin. So they don't have hair, so like we do. They're really built to lose heat rather than keep heat. And because they sit in the water, they've got a lot of blubber in them, which keeps them warm. But what that does is if you imagine sitting in the water in the bath for a while, it's really hot when you go in, but then you adjust to the temperature. It's the same when it's cold. So when it's cold, their body regulates to the temperature of the water, so they don't feel the cold anymore. But what that could do is then mean that their core temperature plummets a bit too low. So it's something we have to be a bit more aware of.
And, well, she's called Haggis. Makes sense, up in Edinburgh Zoo in Scotland. Yeah. Was that a hard decision? Were there a few names floating around, or immediately she was Haggis?
It's always a bit of a thing when you come to name a hippo. Obviously, with keepers and stuff, it's always, you get an attachment to them. But this name came from our welfare charity, and then what they wanted to do is highlight it's a traditional Scottish word, and obviously because she's quite small and brown, the resemblance is somewhat there, I suppose, and it's just to kind of, I think it's to highlight the traditional side of it, but also to try and link Scotland to the nature of the animal, to try and build more awareness through it, because obviously people are Scotland are very traditional, and it's a word that kind of pops up every now and then. I think that's the key to it, is to try and get as much coverage as possible for these animals, to try and get as much help as they can.
Well, we wish Haggis the best of luck. Jonny Appleyard from Edinburgh Zoo, thank you for joining us.
No problem. Have a good day.
Brilliant news to get new animals of rare species. I love the fact that all these zoos across the world work together to get this done. Thank you very much to Jonny for coming on the show. Let's answer one of your questions then. I love this thing. I love this part of the show. If you have anything sciencey that you want answered, anything sciencey at all, make sure you leave it as a voice note for me on the free Fun Kids app. You can send it to funkidslive.com too, and then I'll do all the digging. If I can't come up with the solution, I'll give a ring to one of my favourite experts who's going to sort it out for you. First question this week is from May, who wants to know, how do we see? We see because of light, because it either reflects or is absorbed by materials around us. That's what gives colour, and because of the way our eyes are built. So what happens is light enters the eye through the cornea. That's like a clear window right at the front of the eye. It refracts the light. It bends it in a way so you can get all that light that's in front of you into your pupil, the small black hole right in the middle of your eye. You've also got the iris, which works a bit like a shutter in a camera, right? It makes the image bigger or smaller. It can widen your pupil. It makes it easier to understand. So the light has travelled through the cornea, through that film screen at the front, through the pupil, and then it hits something called the retina, which is at the back of the eye. And that's split into many parts. You've got the macula, which is like a bullseye right in the middle of the retina. It's got all the photoreceptors. And those are nerve endings. So they convert the light into electrical signals, which travel to your brain, which figures out what that means, what the signals are saying, and what colour the light is of what's happening in front of you. So then you can make that image in your brain, May. That's how we see, because of the brilliant way our eyes have evolved to do exactly what we need, and because of the way light interacts with materials around us. Thank you so much. This is from Romi, this is a brilliant question, by the way, Romi. Thanks for sending in your voice note. Let's take a listen.
Hello, Dan. My name is Romi, and I'm from Portugal. My question is, do fish drink water?
Well, Romi, thank you very much for your question. And it sounds so simple, yet like really bizarre to say out loud, doesn't it? Do fish drink water? Let's find out. Dr. Lucy Hawkes is an expert in all things under the water from the University of Exeter. Lucy, thank you for joining us. So, have you ever thought about this before, if fish drink water?
No, I don't suppose I have, but Romi's quite right to ask about it, because it's a really interesting question. And yes, fish do drink water. They can't help but drink water because they've got their mouth open all the time while they're swimming around. And they have to have their mouth open because they've got to get water across their gills. And their gills are just like our lungs. It's the way that they get oxygen out of their environment, which helps them to make energy so that they can move and live and breathe and all the other exciting things they do. But if you're a fish, you've got a couple of different problems. And it depends whether you live in salty water or whether you live in fresh water, like the sort of water that we would drink from the sink. So if you live in salty water, it can actually be quite a big problem, because the saltiness of water is actually much more salty than the inside of a fish is. If you were to take a mouthful of seawater, you'd be a bit like, blech. And that's because it's much saltier than you are. And what's actually happening is that inside your body, it's actually causing water to get pulled out from inside the little bits of your body, inside the bits of your cells, to put the water back in to try and dilute that salt away. So every time a fish in salty water is swimming along, drinking salty water, it's actually constantly pulling water out of the fish. And if anything, actually making it a little bit dehydrated, which means they have to drink lots and lots of salty water. And then also they have to spend lots of energy having special little machines that work on the surface of their gills to actually pump the water back into the fish again, which is a bit complicated and detailed.
Sometimes when you hear about like evolution and how creatures have come to be, it kind of fries your brain a bit, because there seems to have been like a much easier way of doing this. You know, they need to take water into their mouths because that's the way they get oxygen to run through their gills, and that's how they survive with the energy. But by doing that, they're taking too much water. They're having to swallow it, and that could cause them so much harm. So let's draw it way back. Do fish need to drink water, or are they only doing it because it's a side effect of them having to open their mouth?
It's hard to say, because the two things probably kind of evolved together. Yeah, they definitely couldn't avoid drinking the water in the first place. It was always going to go into their bodies with their mouths being open. But that's how they would have started off, trying to get oxygen from the environment as well. So the two are so tightly connected, it's really difficult to separate them.
And if they're opening their mouth all the time, that's drinking a lot of water. And I know you said they need to drink a lot of water because that's the only way they can balance out the huge amount of salt they're putting in. Is there a way Do they stop themselves drinking water if they're a bit full? Do we know? If their mouth's open, do they simply have to swallow? What's happening?
They don't need to pass all of the water through into their tummies, into their digestive system. So they don't get too full drinking it. It's just that it's passing through their gills all the time. But ultimately, what they do is have these special cells, these special factories that sit on the surface of their gills that help to control exactly how much salt and exactly how much water is allowed to pass between the gills and the water. So it's not that they get full so much as they have to change how many of these cells, how many of these little factories are working.
And if you are a fish living in clear water that's not so salty, how much easier is your time? And you don't have to constantly think about this salt and you've not got the cells balancing it out. What's the difference?
It would be much easier to live in fresh water, but you've kind of got the opposite problem, that the fresh water is actually sucking some of the salt out of your body. So rather than you ending up with too much salt, you're actually ending up with not enough. So actually, if anything, you need to work a little bit harder to make sure that you don't lose too much of the salt. And again, those special cells, those special factories on the surface of the gills have been specialized to make sure you can do that. Now, there's one more crazy thing, which is that some fish, like salmon and trout, can spend part of their lifetime in salty water and part of their lifetime in fresh water. So that's even crazier. So they're having to change the way their bodies work and the way these little cells work on the surface of their gills as they're traveling between these two environments. But I like to think of it's probably a bit like us. I could go on holiday somewhere nice and hot and put my bikini on, and then I can come back to the British wintertime and put my coat on. It seems crazy to other animals maybe, but to me, I'm like, no, it's okay. I can cope. I have strategies.
Well, Romi, who'd have thought that your question, do fish drink water, could open up such like a minefield of diving into the evolution of fish and how one is different from the other. I mean, spectacular. Thank you so much, Romi. And thank you, Dr. Lucy Hawkes from the University of Exeter. Thank you for joining us. How fantastic is that? Well, of course, fish drink water. They're surrounded by it. What else do you think they're going to do? Brilliant question, Romi. If you have anything sciencey that you want answered next week on the podcast, make sure you leave it for me as a voice note on the free Fun Kids app. You can click the record button there, and at funkidslive.com too. I'll get it on next time and we'll get a genius to answer it for you. Let's get to this week's Dangerous Dan, where we take a peek at some of the most weird, strange, unique and often deadly things in the universe. This week it's about a tree that's so deadly and explosive, it's nicknamed the Dynamite Tree. The Dynamite Tree is also known as the sandbox tree. It's found in the tropical warm parts across the Americas. They can be huge. They can grow to 200 foot high, almost 50 foot around. It grows small red flowers. Its trunk is covered with long, sharp spikes, and that makes a poisonous sap, which causes incredibly itchy skin. It can even make you go blind. But that's not the most dangerous part, not the sap or the spiky trunk. Almost every part of this tree wants to do you damage, including its seed pods. Across the tree, it grows these seed pods. They look a bit like a pumpkin, and they're full of seeds, so the tree wants to scatter those seeds everywhere so it can make little baby trees. And when these pods get so big, they explode. They fling these seeds across the area nearby. It makes a loud bang. And these seeds launch at speeds of up to 160 miles an hour. They spread 30 meters away. If they hit you, they will hurt. These seeds smashing right into you with such pace, they'll cause an injury. So just think about this tree. Every part of it wants to hurt you. It's got a spiky trunk. It makes a poisonous sap. Even if you're not that close to it, it will shoot a seed at you. It will explode stuff in your direction. And that means the sandbox tree, I prefer calling it the Dynamite Tree, that makes it go straight onto our Dangerous Dan list. This week on Battle of the Sciences, we're seeing what's happening inside your brain. And we've looked at so much. We've looked under the ocean. We've looked back in time. We've looked across the universe. Now, it's what's really happening in your brain. Professor Magda Osman is from Leeds University. It's all about decision sciences. Magda, you have 1 minute to tell us why decision sciences is the best science of all. It starts in 3, 2, 1, go!
For every single thing that we do, we have to make a choice. Some of those choices are basic, like who we make friends with, how we spend our time, and what we prefer to eat. But as we get older throughout our lives, we make choices that get more and more important. This is because we're social creatures. So we make choices in large groups like voting that impact all of us. Also, others make choices for us like schools, government, large companies, even AI. So how do we make decisions? How do others make decisions for us? And how do we judge if a decision is good or bad? If we don't know the answers to these questions, then we can't make our lives and those of others around us better. So decision sciences is there to give practical answers to these life-changing questions.
Well, there's your minute. A little under as well. So we were good. Now, I mentioned at the start that I've spoken to a lot of different experts who maybe are looking across the universe, or they're digging up fossils from millions of years ago. Now, when they're doing that, you can almost see the outcomes of why they're doing it. You can figure out what they're measuring and kind of spot why they're doing it. With decision sciences, how is what you're learning changing the future? How are you putting that knowledge into practice?
Because even for any other science, you have to make a decision, right? So you have to choose what you're going to study. You're also going to have to choose how to study it. And you have to determine what the right measurements are, right? So that's why I'd argue what decision sciences does is crucial to all other sciences. So the impact in terms of what we measure in our discipline, so decision sciences, is virtually everything. So how the stock market works, and how we invest our money, who we decide to marry, right? So all of those things have very tangible outcomes, right? So you want to then still be able to know, how did I get to this thing that I did, whatever that is, like what I bought, who I married, where I live, why I'm choosing this option for studying at school over another one, right? So all of those are really concrete things, but we need to know how to do those things better, because sometimes things don't work out and you want to know why that didn't work out. Is it because of terrible things that are happening outside, or because we're just making sort of silly decisions?
How much have we figured out the balance between the biology of this is what we've always thought, and this is what we kind of grew up thinking, and this is what our parents and our grandparents thought, this is what we're hardwired to decide, and what we've learned, and kind of external factors? How much have we figured out that balance, Magda?
It's a great question, because we might be able to excuse ourselves by saying that, oh, it's my brain, or it's my genetics, or whatever. Some of that plays a role, but it's always useful to remember that you can do things yourself in spite of your biology, right? So while we might be constrained in some ways and find it a bit difficult because some things are harder to learn or think about, we can all get better, right? So that it's not that everything is so fixed that we can't change anything about our lives. So that's the positive thing that comes out of the work that I do and various people around me, which is there's possibility for all of us to change and improve. So it's not just because we're stuck because of our genes or whatever else.
Are humans selfish people? In everything that you've studied so far, like, are we selfish, or are we thinking of everyone else?
So we have to prioritize ourselves at some level, but because we're social creatures, we have to make collaborative decisions, right? And that's actually one of the hardest things to study, which is how we work with others to make group decisions. And that can be really mundane, like, where we go to eat together, or something even major, like a government. So we are making decisions on behalf of others, but we have to be somewhat selfish because we have to think of ourselves. So it's not necessarily just one or the other, right? Because in many cases, we have to do a bit of both, right? So it's not that we're just fundamentally selfish. It's just that we have to tilt towards prioritizing ourselves, because ultimately we're the ones that have to look after ourselves. So there's that, but I don't think it's that humans are sort of fundamentally just totally selfish.
I like to ask questions about the past and the future. So in your work so far in decision sciences and moving through all forms of psychology. What's been the most mind-blowing thing that you've ever learned?
The thing that I think is the most curious is that even when it looks like we have no choice and we're backed into a corner, if you ask people, they'll always say, on some level, no, there's still a little bit of choice that I have. Right. So that's the problem for philosophers and other disciplines, right? Because they all want to say, no, ultimately we don't have choice. Like there's some big grand theory about all of this kind of stuff. But actually, if you ask people, they're very practical, and they fly in the face of the big theorists and scholars and that kind of thing. So I think it's the most interesting for me because it shows if you ask people and try to understand how they think, what they want to say is that I still want to feel like I have some choice over the things that matter to me. And that's quite a big thing. It seems quite basic in one sense, but it's just from the rest of the field, they don't necessarily like that kind of finding.
Let's move to the future. So in years and years and years, whenever it is, Magda, that you decide you're done with your day job, you don't fancy it anymore, what's the one thing that you really want to discover? What's the one question that you want answered in your field?
We have to make decisions about ourselves and other people on the basis of whether people are good or bad, right? So that's a kind of moral aspect. The thing that would be really great to know is whether we could build a theory or a tool to be able to tell us, yeah, that's bad. That's good. Someone did a really bad thing. So we have laws and things like that to help, but those keep changing, right? So it would be just useful for us to be able to have a little kind of template somewhere where we can go, yes, that's definitely, everybody thinks that's terrible.
Well, I guess my last question, with the rise of AI technology, you would think that would help us make the correct decision, because a computer can instantly scan through the internet, look through all the examples of anyone that's made a similar decision just like this and say, actually, this is what you need to do. Is there a worry, though, Magda, that by giving every choice to a computer, we stop becoming human?
Yeah, that's a brilliant question. We won't, at least, I think, in the next 20 years or so, allow a computer to make a decision for everything that we do. In fact, that's one of the things that the work in my field is looking into, which is what things are we happy that computer or machine will make for us, and what things do we need to still keep for ourselves that makes us ultimately human. So I don't think it's an either or. I think it's just we need to figure out where the things are that we're happy to just offset to a machine, and the other things that we want still to keep to ourselves.
Well, now it's your decision. Is decision science is the greatest science of them all? We'll find out. Professor Magda Osman, thank you for joining us. What do you think? Decision science is everything that's happening in your brain? Is that high up the leaderboard for Battle of the Sciences? I wonder. We'll have a new one on next week on the show. Earlier on, we heard from Lucy Hawke, didn't we? She was on helping us find out whether fish drink or not. It's got me thinking about other things that happen under the ocean. So let's catch up with one of our favourite experts, Marina Ventura. This is an episode from her podcast series, The Ocean Adventure. And we're hearing all about the genius ways to track sea life. And Marina, along with her trusty sidekick MapApp, can find out how we know what creatures lurk under the ocean.
Deep Space High, the Galaxy Gala with the Royal Astronomical Society, advancing astronomy. Jump into a wormhole, travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
Okay, settle down. Okay, we've now made some great planets, show-stopping nebulas, and an array of dazzling stars. There's just one problem. We haven't decided what to put them in yet.
How about a cardboard box, miss?
No, I mean what type of galaxy. Galaxies are collections of all those different cosmic contents, held together by gravity.
Aren't all galaxies the same?
No, they come in a variety of sizes. Out of the billions of galaxies in the universe, some are very small with only a few million stars, while others are huge with over 400 billion stars.
Let's have a Whopper, miss.
If you like. But we don't just need to decide on size. We also need a shape, and there's different types of those, including elliptical, spiral, and irregular.
That reminds me, what's a galaxy's favourite game?
Oh, here we go. Another terrible joke. Go on. What is a galaxy's favourite game?
I spiral.
Thank you, Quark. Right. To find out more about the different shapes, we're going to play Galaxy Top Trumps. Sam, you're playing the elliptical galaxy cards. Here they are. Can you describe what the galaxies on your card look like?
Looks like they're mostly an oval shape. Quite smooth. Some of them have rings around them, but they're pretty simple. A bit boring looking.
Quark, you can play the spiral galaxy cards. Here you go. Can you tell us what the galaxies on your cards look like?
Cool. Well, they're spiral shape, of course. They're really pretty. Some have 1 or 2 twisty arms around the middle. Some have loads. They look like whirlpools. They all seem to have a big bulge in the center.
Electra, you can play the irregular galaxy cards. They're the ones that don't fit into the first 2 types. Astronomers think that some were made by other galaxies crashing together. How would you describe them?
Wow! Well, they look like all sorts of shapes. Blobby ones, stringy ones, and some are very lumpy bumpy.
Right. Cards at the ready. Let's have round 1. Which galaxies are biggest?
Well, my regular galaxies are a bit of a mix. Some are big, some small.
Same here. There's certainly some pretty big spiral ones.
Ha! I bet you can't beat this elliptical whopper. The card says it's called IC1101, and it's 60 times bigger than the Milky Way, with 100 trillion stars. Elliptical wins.
Well done. Elliptical galaxies are generally the largest in the universe. So Sam wins that round. Let's try another. Round 2. Which type of galaxy produces most new stars?
Elliptical have rotten scores. It looks like they're pretty quiet. No new stars made on any of mine. I'm out. Irregular galaxies can make stars. I've got one here called IC10. That scores high.
Well, my spiral galaxies beat you hands down. Look. Loads of them are top star makers. Messier 100, Andromeda, and a massive one called the Whirlpool Galaxy.
That's right. Spiral galaxies are often teeming with bright new stars. Those dusty arms that make up the spiral actually cause new stars and planets to grow. There's time for one last round. Which type of galaxy is the rarest?
I've got loads of cards. Looks like spiral galaxies are pretty common.
Oh, me too. Look, I've got even more cards than Quark. Irregular wins. I've got the least cards of all.
Well done, Electra. You're right. Irregular galaxies make up only about 5% of all galaxies, so they're the rarest type. Well, as you can see, there's no clear winner. Every galaxy type has something special to offer. So, which type shall we have for our Galaxy Gala?
It's pretty hard to choose. Can't we have a mixture of types?
Or more than one?
Why not? Galaxies do collide, and they often sit in groups. Your Milky Way is a gang of 6 called the Local Group. Maybe we could have the Deep Space High group of galaxies. Oh, but we'll have to talk about that the next lesson. We're out of time for today.
Deep Space High, the Galaxy Gala with the Royal Astronomical Society, advancing astronomy.
And that's it for this week's Fun Kids Science Weekly. Thank you so much for all of our genius friends for coming on the show, for answering your questions. If you have anything sciencey that you want answered next week on the podcast, make sure you leave it as a voice note for me on the Free Fun Kids app or at funkidslive.com. You've heard Marina Ventura today. We've got loads more brilliant podcast episodes wherever you get your shows. They're on Google, Apple, Spotify, on our app and on our website too. And Fun Kids are our children's radio station from the UK. Listen all over the country on the Free Fun Kids app at funkidslive.com. And if you've got a smart speaker, wake it up and ask it to play Fun Kids.